Simplify and express your answer using positive exponents. Now we're starting to look at some negative exponents, and we'll start with some of the simpler kinds of problems with negative exponents. If we just take a look at the negative exponent rule, this first form of it is the one that is most often given in textbooks as the definition of the negative exponent rule. Note that this means when we have a negative exponent, the expression moves into the denominator and the exponent becomes positive. So this first example, we can use this form of the negative exponent rule. We just need to identify all of the factors that are taken to negative powers. In this case, 5 to the power negative 2 and b to the power negative 1 are both taken to negative powers, and a to the power positive 3 is not, so it's going to stay exactly as it is. So let's apply this negative exponent rule directly. That would become 1 over 5 to the power positive 2, and this b to the power negative 1 would become 1 over b to the power positive 1, and our a cubed would stay exactly as it is. And just to help this make sense, I'm going to write that as a cubed over 1. Putting an expression over 1 does not change its value in any way. And now I can merge these together by multiplying straight across on the top. 1 times a cubed times 1 is simply a cubed. And 5 squared is 25. When we multiply that by 1 and by b to the power 1, we simply get 25b in our denominator. So a simpler way of thinking about this negative exponent rule that will work in more cases than what we've seen here is to say that not only can something move from sort of floor level or the numerator into the denominator, but something can also move from the denominator out of the denominator, making that exponent also become positive. In a simpler way even to say it than that is that these factors can move back and forth across the fraction bar if they have a negative exponent. So what that says is that factors with a negative exponent can move across the fraction bar to the other side, making the exponent positive in that move. If we now go to the next example, this way of thinking about the negative exponent rule is going to be much simpler than any other way we could think of it. We just want to grab any factor that is taken to a negative power and move it to the other side of the fraction bar, making that power positive in our first step. So what I see is that y to the negative 2 in the numerator and x to the negative 3 in the denominator are the two factors that we're going to move. The x in the numerator and the 3 in the denominator stay where they are because neither of these factors is taken to a negative power. Y to the negative 2 moves down and becomes y to the positive 2. X to the power negative 3 moves up and becomes x to the positive 3. After taking care of all of the negative exponents, we're ready to go ahead and apply other properties of exponents if required. In this case, we can see that we have x times x cubed in the numerator. That's x to the power 1 times x to the power 3. So I'm going to go ahead and combine those using the product rule, which is the rule telling me to add the exponents, so that I get x to the power 4 in the numerator and 3y squared in the denominator. At this stage I know I'm done because all of my exponents are positive and there is no other simplifying that can be done.